Hendrik Makaneta, and we are going to start with our grade 9 lesson for today. And as always, I hope that you will be able to take the time and the trouble to ask if there's any clarity-seeking question. If you have a question, please feel free to ask at any time, and so that we don't leave you behind. Now, as we welcome other participants, I'm just going to start with our lesson. And of course, at the end of the lesson, you are free to send any message either on my Twitter account or via WhatsApp is fine. And today we are going to factorize algebraic expressions. In particular, we will look at the difference of two squares. So we'll do our normal factorization, which we have just started. And of course, we will focus a lot on the difference of two squares. And I hope that this will be a very exciting and informative lesson, which can help you when it comes to factorization. Now, without any waste of time, I want us to look at the example here, which is example 1. And what is important there is to be able to see that we have got an example which is 2x minus 6x squared. Now, how do we factorize this example there? You can see that in both cases here, we have a common factor. So what is important is that we need to develop the capacity to identify common factors. And in this case, 2x is our common factor there. And of course, if you subtract, if you take out the common factor 2x, you will be left with 1 in this space, because 2x times 1 gives us 2x. And in this case, you will be left with 3x. You must always bear in mind that whenever you take out a common factor, you should be able to use your solution to find the original expression. So we will see that if you have to test or to check whether your answer is correct, you'll have 2x times 1 is 2x, and 2x times 3x is 6x squared. One other way of looking at this is to check your numbers first. You can see between 2 and 6, what is the common factor there? The common factor will be 2. So you take out 2, and in this case, you'll be left with 1, and here you'll be left with 3, because 2 times 3 gives you 6. Then you come to the variables. The first part there, you have x, and the second part, you have x squared. So obviously, if you take out x, you'll be left with 1 there. And then if you take out x here, you'll be left with x, because x times x is x squared. So basically, you'll have 2x, open bracket, 1 minus 3x. That will be your answer in as far as factorizing this expression is concerned. And of course, I'm just going to carry on with the next example, where we will also factorize the expression. And of course, the second example, as you can see, we have the following. In this case, you have 2 open bracket x minus 1. Now, this is what you have, 2 open bracket x minus 1. And of course, if you look at the expression there, who can tell me what is the common factor there? How did we arrive at this point where we have taken out x minus 1 and then, of course, 2 minus 1? How did we find it? Who can tell me what is the common factor in this expression here? Do you see a common factor there? If you see a common factor, please raise up your hand and tell me what is the common factor there in example 2. If you can see a common factor, just raise up your hand and then tell me what is the common factor there. What is the common factor? Right, let's go to, let's see, just to identify, All right, I see there's one hand. Unkabetsi, please go ahead.
Morning, sir.
Yes, Unkabetsi.
The common factor is x minus 1.
The common factor is x minus 1. Yes, I fully agree with you. The common factor there is x minus 1. And then you can see that once you take out x minus 1, what will be left, Unkabetsi?
It will be 2 minus a.
It will be
2 minus a.
2 minus a. Indeed, you will be left with 2 minus a. You can see that we have 2 this side and we've got minus a this side. And of course, once you take out the common factor there, you'll be left with 2 minus a. And indeed, that will be our common factor there. Now, I want us to carry on just to look at the third example, because we do have the third example there where we are just going to factorize again. So if you look at this example 3, you will be able to see that this is the what we call the difference of two squares. Now, in this difference of two squares, we have x squared. This is a square, and then we also have minus y squared. So the difference means we are subtracting. So you are subtracting one square from another. Now, in this difference of two squares, you'll be able to see that once you take out the common factor there, this will actually emanate from this expression where you were multiplying the two, where the middle term will give you 0. If you look at how we have done it here, we have said that x minus y, open bracket, x plus y. So you open the bracket, you put x minus y, and you put x plus y. That's basically what you do when it comes to the difference of two squares. And the reason for this is that when you multiply out x by x, you'll get x squared. And when you multiply x by y, you get xy. And when you multiply negative y by x, you get minus xy. And the two will cancel out. And the last part will be negative y times positive y there. And that will give you negative y squared. So basically, this is where we are in as far as the difference of two squares are concerned. And later on, I will give you an opportunity to write, and find the difference of two squares. But I wanted to show you that the difference of two squares means there's nothing in the middle. There's no middle term. That's why you only have this term x squared and y squared at the end, and you are subtracting. So it's different from x squared plus y squared. It only works with x squared minus y squared, where there is no middle term. And of course, you can continue to write it as x minus y into x plus y. Remember last week when we did our algebraic expressions, I said that if you have to multiply, so if you want to test whether this answer is correct, you simply multiply this whole bracket here by the first one. So meaning that you have x into x plus y, and then you have minus y into x plus y. And of course, once you have multiplied them together, you'll be able to see that we will have the final answer is x squared minus y squared. And that will be your original expression there. So the difference of two squares, very important. All that you do, you take the x and the y. You are going to use x and y. In the first bracket, you have x and then y, x and y. Then you put negative, and then this side you put positive. Alternatively, if you can put positive in the first one, and then you can put the negative in the next expression then. That will be your factorization of the difference of two squares. Is there any question up to so far? Maybe let's entertain. Unkabetsi, I see your hand is still up. Unkabetsi? Right. So we are done with example 3, and then we'll proceed to the next example. So you can see that in the next example as well, we have an expression there which we need to factorize. The first expression being 3a open bracket a squared minus 4. And then you can see that this is minus 7a squared minus 4 there. And that is example 4. And then, of course, what is important is to realize that you can take out this as the common factor, a squared minus 4. That becomes your common factor because it exists in both sides. And of course, this will be, the remaining one will be 3a minus 7. So 3a minus 7 will be your final answer there. So of course, again, you can be able to factorize this one. You can see a squared minus 4. That on its own is also the difference of 2 squares. And then once you factorize it, you will be able to see that this will be a square, this will be a minus 2, because remember 4 is the same as 2 squared if you were to write this as the difference of 2 squares. It is a squared minus 2 squared. So you will still have to now write it down as a minus 2 and then into a plus 2. So that will be your expression there. So as you can see, we're going to now look at activity 1, which I want us to factorize. The activity says, factorize the following expressions. 1, you have a squared, open bracket, a minus 1, and then minus 25, open bracket, a minus 1. Again, if you look at how we have approached this, you can be able to tell that we have a common factor. And in this case, the common factor is a minus 1. Even here, the common factor is a minus 1. So now once you take a minus 1 as the common factor in both expressions, you will be left with a minus 1 and then open bracket a squared, this a squared here, minus 25, this a negative 25 there. So it means at this point, you have factorized your expression there. But it does not end here. You can see again that a squared minus 25, that on its own is the difference of 2 squares. That's why I said here, a squared minus 25 is also a difference of 2 squares. And what are the squares there? A squared minus 25. 25 what is a square number. You remember when you did square numbers in grade 8, 25 is a square number. Why is 25 a square number? Because you can square 5 in order to get 25. So meaning that this expression is the same as a squared minus 5 squared. That is why when you factorize it, you are going to say a squared minus 25 or a squared minus 5 squared will be a minus 5 into a plus 5. That will be the expression, and which brings us to the final answer. Now that you have factorized a squared minus 25, then you should be able to see that your final answer there will change, and it will become a minus 1 into a minus 5 into a plus 5. So that is the first activity there, which I thought we must be able to do and be able to finalize. That was the first activity. And of course, the next one, it's quite a broader activity of the expressions there, which I want us to factorize. So this activity 2, we are going to do it together, where you have got x squared minus y squared. But before we can go to this activity, let me take you back once again to the work that we've done so far. we have been able to see here that you can be able to factorize this in example 1. You have the expression there, 2x minus 6x squared. And once you take out the answer there, 2x, you'll be left with 1 minus 3x in the next category there. So meaning that your final answer will be 2x into 1 minus 3x. And that is your factorization as it stands. And secondly, example 2 there, as you have just managed to see, we have 2 open bracket x minus 1, and then minus a into x minus 1. And then, of course, once you take out x minus 1, you should be able to see that you'll be left with 2 minus a. And of course, that will be your factorization. And example 3, once again,
Sir,
this is the difference of 2 squares, yes?
may you please explain example 1 again?
Okay. I'm just going to explain it. Example 1 there, you can see that when we factorize, maybe let me start by factorizing the numbers first. Maybe before you go to the variables, let's start with the numbers. The numbers that you see there is 2 and 6. I'm sure you can see 2 there. You can also see 6. So those are the numbers. So let's start with the numbers. When I say give me the common factor between 2 and 6, what is the common factor? Meaning that, what is that
It's
number
3.
that can go? Come again?
It's 3.
3.
It's
Is it
2.
3?
It's 2.
It's 2, because in this case we have 2. We don't have 3, we have 2. If it was 3 and 6, yes, the common factor was going to be 3. But because we have 2 and 6, here you will take out 2. That's the only factor there. And then you also take out 2 this side. So the common factor there will be 2. And remember, maybe before we carry on, let me refresh your minds. How do you define a common factor? Who can tell me what is a common factor? Maybe before we start, so that we can see that we are all on the same page. What is a common factor? Who can tell us what is a common factor? I don't see hands yet. What is a common factor? Yes, Unkabetse. Unkabetse.
Sir, it is the number it can be divided into.
A number that can be divided
Into.
by 2. All right. Perhaps if we put it differently, let me ask you, what is the common factor of 12? Or what are the common factors of 12? Common factors.
It's 1, it's 2, 3, 4, 6, and 12.
Yes. Now, what do you notice about those numbers that you've just given me? You said it's 1, 2, 3, 4, and 6, and also 12 included. Even 12 is the factor of 12. What do you see? Or what is something that is common about these numbers? The number 1, 2, 3, 4, 6, and 12. We say that they are the factors of 12. They are the factors of 12. Why are they the factors of 12? What is common about them? Yes, again, let's go to Unkabet's again. Unkabet's, what is the relationship of these numbers that you just gave me? What is their relationship with 12? Okay, you have just, let me put it differently now. You have just said 1, 2, 3, 4, and 6 are common factors. Let me ask you, why is 1,5 not a common factor? Why don't you use decimal fractions? Why do you take only whole numbers? Why do you define common factors as only whole numbers? That is because if you look at these numbers, they can go into 12 without any remainder. So when we talk about common factors, those are numbers that can go into another number without a remainder. For example, if we look at this example 1 here, 2 is a common factor of 6. And 2 is also a common factor of 2, because 2 can go into 2 without the remainder. 2 goes how many times into 2? It goes once. How many times does it go into 6? 3 times. So that's why we say 2 is the common factor there. So once you take out 2 as the common factor, you'll remain with 1, because 2 into 2 goes once. That is why you have 1 there. 2 into 6 goes how many times? 3 times. That is why you have 6, you have 3 there. And you do the same with x. You have x here, and then you have x squared on the other side. Now, what is the common factor there? X can go into x. How many times? Once. X into x goes how many times? Once. And x into x squared goes how many times? It goes x times. Because remember, x squared is the same as x times x. Now, if you divide x by x, if you divide that by x, one of the x will cancel out, and then you'll be left with x. Therefore, to factorize this expression 2x minus x squared, all that you need to do is to take out 2x, and then you'll be left with 1 minus 3x. And to test whether your answer is correct, as I've said, you need to now multiply out the bracket there. 2x multiplied by x, 2x multiplied by 1 will give you 2x. And of course, minus 2x times 3x gives you 6x squared. And of course, that brings us to the conclusion of factorizing 2x minus 6x squared. This will be 2x minus 2x into 1 minus 3x. I hope that it makes sense as we look at example 2. Now, example 2 can be quite tricky if you are not careful. It can be a bit tricky because we have common factors, but some learners may not be able to see the common factors. What is important is to look at your brackets. Look at those brackets. You have got 2 open bracket x minus 1. And then minus a open bracket x minus 1. And you can tell without any doubt that the common factor there, the expression, the binomial x minus 1, it appears twice in these expressions. It appears in the first term where you have 2 into x minus 1. X minus 1 appears again in the second term of our binomial, which is negative a open bracket x minus 1. Can you see that we have now spoken about x minus 1, which appears twice. It appears here in the first term. It also appears in the second term. Now, at this point, you can take out the common factor, and correctly so, that will be x minus 1. That will be x minus 1. And once you have taken out x minus 1, you will be left with 2, that is the same 2 there which we had, and then minus 1. So in other words, your final answer there will be open bracket x minus 1, which is your common factor, and then you open your bracket, and then you'll be left with 2 minus a. That will be your final answer there. So in other words, once factorized, you have x minus 1, open bracket, 2 minus a. That will be example 2 of factorization. And I hope that I've managed to explain it thoroughly. Now, I'm going to explain the example 3 now. And you can see that this is what we call the difference of two squares. And sometimes it can be tricky. I want you to forget about the plus sign now, the x squared plus y squared. We will come to that when we deal with the trinomials, or when we factorize trinomials, we will come to that. But for now, we are factorizing the difference of two squares. And why do we call this the difference of two squares? Maybe let me start there. Is there any learner who can explain to me, why do we say x squared minus y squared is the difference of two squares?
Because there's a minus sign.
Yes, because there's a minus sign. And again, what about the squares? Are there any squares there?
Yes, sir.
Yes, what are, mention those squares?
It's x squared and negative y squared.
It's x squared and y squared. And they are separated by the minus sign or the negative sign, meaning that this is the difference. Remember, when we talk of the difference, we are talking about subtraction. When you say what is the difference between 10 rands and 2 rands, what is the difference? 10 minus 2 is 8. So that is the difference. All right. Now, we also have the difference of two squares, x squared minus y squared. That is the starting point now. We call this the difference of two squares. Now, wherever you go in mathematics throughout your academic life, if you carry on with maths, even beyond grade 9, let's say next year in grade 10, you should always remember this, that when you factorize the difference of two squares, you are going to factorize them as follows. You are still going to use x and y. So you'll open the two brackets now, the first bracket here, pair of brackets, and the other pair. And then you put x here in the first bracket. You also put x in the second bracket. Then you put y, you also put y there. Why? Because that's the difference of two squares. And then when it comes to your sign, if you allocate a negative sign in the first bracket, then you must allocate a positive sign in the second bracket. If you allocate a positive sign in the first bracket, then you'll allocate a negative sign in the second bracket. That's how you solve the difference of two squares. That's how you factorize the difference of two squares. And by so saying, you have factorized it, you are done. That is how you factorize the difference of two squares. as we admit Kaden into the lesson. That's how you factorize the difference of two squares. So today you are going to work a lot with this difference of two squares. As I've said, I'm going to give you an opportunity to reflect on the difference of two squares in the examples that will follow. But perhaps the last one is to look at example 4. And in this example 4, just before the last, just before activity 1, we have said that if you are given this expression here, 3a into a squared minus 4, close bracket there, minus 7 into a squared minus 4, you will be able to see that the common factor there between the two expressions, or between the two terms, rather, the common factor there is a squared minus 4. Why is it a common factor? It appears in both terms. The first term in this case is 3a, open bracket, a squared minus 4. Then you close your bracket. That's the first term. So basically, you have got two terms in this expression. And the first term is 3a, open bracket, a squared minus 4. Then you close your bracket. That's the first term. The second term is 7, open bracket, a squared minus 4. Then you close your bracket. That's the second term. And these two terms are separated by a negative sign. The two terms are separated by a negative sign. Yes, user, I see your hand is up.
Sorry, sir. While doing factorization, sir, is it basically like we're simplifying the term, or not simplifying it, sir, but making it shorter, sir, by adding or combining the terms together, sir?
Okay, I did not get your question correctly. So are you asking me if we are simplifying?
No, sir. Like, are we making it shorter, sir? Like,
okay. Yes, well, not necessarily shorter, because if you look at the, yes, actually you do. You can say that you are making it shorter. If you look at the previous example here, this was x squared minus y squared. That's the difference of two squares. Yes, definitely. You are making it shorter in a sense that if you look at the next answer there, that is only one term. X minus y, open bracket, x plus y, that's just one term because it's a product. You know, when there's a multiplication sign, it makes it only one term. So you have moved now from two terms, x squared being one of the terms and then y squared being the second term. So yes, you are shortening it in a sense when you factorize. I agree with you. Tim, is that Tim?
Yes, sir, Tino.
Tino, yes. Thank you very much, Tino. Let me carry on now to say the second one, you do the same. You can see that we have a binomial. This whole expression here is a binomial. Although, you know, someone may not be able to see that this is a binomial, it is a binomial. Why is the binomial? The first term is 3a, open bracket, a squared minus 4. That's one term. That is just one term. And then the next one, 7 open bracket, a squared minus 4. That's also another term. So you have two terms, basically. So yes, you are shortening it. And now all that you need to do is to factorize by taking out the common factor. As we have said, the common factor in this case will be a squared minus 4. That is the common factor. And of course, if you take out the common factor, you'll be left with 3a minus 7. Basically, that is what you'll have. But then again, I've said to you, you can actually factorize this even further. Because if you look at the previous example of the difference of two squares, you also have the difference of two squares here in the form of a squared minus 4. because 4 is the same as 2 squared. Therefore, if you have a squared minus 4, that will be the same as a squared minus 2 squared. And then you can factorize that as well. You can factorize that. You'll have 2 brackets, and then you'll have a minus 2 into a plus 2. I'm talking about this term here, a squared minus 4. This becomes a minus 2 into a plus 2, and then into 3a minus 7. So that's how you factorize the expressions. Now, in activity 1, again, you can be able to tell that once you factorize this expression, you look at the 2 terms. The first term, you have a minus 1. That is what you have as the common factor. It is there in the first term. A minus 1 is found in the first term. It is also found in the second term. So you can see we have a minus 1 here. We also have a minus 1. So you can take it out because it is a common factor. So once you take out this common factor, you'll be left with a squared minus 25. So basically, once you have factorized it, you'll have a minus 1 open bracket, a squared minus 25. But then again, just like I've done with the previous one, you can see also that a squared minus 25 is also a difference of 2 squares, because 25 is the same as 5 squared. Now, at this point, you can factorize a squared minus 25. And how are you going to factorize it? By taking out now your bracket, you'll have a minus 5 into a plus 5. And if you want to test it really, you can just multiply out the 2 brackets and, a minus 5 by a plus 5. It will take you back to a squared minus 25. And now that we have factorized a squared minus 25, then you can come back to your original equation there, in fact, expression. Then instead of a squared minus 25, you can write a minus 5 into a plus 5. That's how we have written it at the bottom there, that the final factorized expression will be open bracket a minus 1, close bracket, open bracket a minus 5, you close your bracket, open bracket a plus 5, then you close your bracket. That will be the factorized version of the original expression here, which was a squared, open bracket a minus 1, minus 25 into a minus 1. So the factorized version of this expression is a minus 1 into a minus 5 into a plus 5. And then, of course, that being said, we also have this activity 2, which we need to factorize. Remember, this is the difference of 2 squares. I've already done the first one for you. If you remember in example 3, we've done that. But just to recap, can you tell me what will be the factorized version of x squared minus y squared? How are you going to write it out? Yes, Tino?
We're gonna write x minus y, sir. And then we first can open brackets and then we close brackets by y, sir. And then we open brackets again, and then we write x plus, change the thingy, the sign, sir, and then we put y and then we close brackets, sir.
Exactly. So basically, as we have done in the previous example, you can see that we will have open bracket. Please don't mind the first bracket there. We should have just one bracket here. It will be open bracket, so you can scratch out this other bracket. So it will be open bracket x minus y, then you close your bracket, open bracket now, x plus y. So that's how you factorize the difference of two squares. So the final answer there will be x minus y into x plus y. By the way, you are not forced to start with x minus y. You can also start with x plus y. But once you start with x plus y, you must know that the next term there will be x minus y. So you must have a negative and a positive in each case. Right. Let's go to B now. Let's go to number 2. Let's
Sir.
factorize the second one. A squared minus B squared.
It's a minus b in the bracket,
Yes,
and then open the bracket again, a plus b, and close the bracket.
exactly. Exactly. It will be A minus B in bracket, and then open bracket A plus B. That is how you factorize it. That is how you factorize the second one as well. Can we go to the next one, which is number 3? Can we get a different participant now in this case? All right, it's Tino again. Tino is back. Yes, Tino, go ahead.
We open brackets, and then we remove the squared, and we just place p minus q, and then we close brackets,
All right.
and then we open brackets again, and then we put p, and we change the sign, and it will be a plus, and then
Exactly.
we use and then close brackets.
Exactly. So that's what you do. You just simply remove. I like the fact that Tino just said you simply remove the squares. You remove the 2, you remove the 2 there, and you are left with p minus q. You put that in the bracket. And thereafter, you open the bracket again, then you have p plus q. And then you are done. The next one, k squared minus s squared. Bitsogo, are you still there? Let's go to Bitsogo.
So I say open bracket
Yes.
minus s close bracket
Okay.
open bracket k
No.
plus.
All right, just carry on, Bitsogo.
Did we do 4?
No, we are in 4 now. We are doing 4.
Oh,
What
I
what
said
will be? Okay, you were just about to finish 4.
yes, which is k plus s, then close bracket.
Okay, can you restart the first bracket there? I didn't hear you correctly. What will be the first bracket?
K minus s,
Okay,
then k plus s.
exactly. So you'll have k minus s, and then you open the bracket k plus s. That is how you will proceed in as far as this expression is concerned. And last one. Can I get a different hand for the last one? Okay, let's go back to, okay, let's go back to,
Sir.
all right, Kai, your hand is up. Kai? What
Yes,
will
sir.
be, yes, what will be your answer there for the last
Open
one?
brackets. Open brackets. W minus Z close brackets. Open brackets. W plus Z close brackets, sir.
Exactly. Exactly. So you'll have open bracket W minus Z, close bracket, and then open bracket W plus Z. So basically that is what I wanted you to learn today. That is factorizing the difference of two squares. I hope that you will take the time to reflect on this activity too. And perhaps if you have any question, just feel free to ask me. But tomorrow, we'll just do a little bit of factorizing the difference of two squares and the other factors related to the two. And then on Wednesday, then we can factorize the trinomials. So we'll factorize the binomials. We'll continue tomorrow, and then on Wednesday, we'll start with trinomials. Thank you very much indeed. Once again, let's continue to, these are just the answers that you gave. And of course, the last one was W minus Z into W plus Z. That is how we factorize the difference of two squares. So we'll continue with factorization tomorrow. Feel free again to contact us on Africa Team Geeks. At Africa Team Geeks, that is our Twitter page. We are also on Facebook. And of course, this lesson was brought to you by the Lockdown eSchool in partnership with the Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.
Bye, sir.
Bye.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.